theme tune. Anyway, S. Hawkman, as you'd seen, the next episode. General relativity predicts that heavy objects that are moving will cause the emission of gravitational waves, ripples in the curvature of space that travel at the speed of light. These are similar to light waves, which are ripples of the electromagnetic field, but they are much harder to detect. Like light, they carry energy away from the objects that emit them. One would therefore expect a system of massive objects to settle down eventually to a stationary state, because the energy in any movement would be carried away by the emission of gravitational waves. Brackets. It is rather like dropping a cork into water. At first, it bobs up and down a great deal, but as the ripples carry away its energy, it eventually settles down to a stationary state. Closed brackets. For example, the movement of the Earth in its orbit around the Sun produces gravitational waves. The effect of this energy loss will be to change the orbit of the Earth so that gradually it gets nearer and nearer to the Sun. Eventually collides with it and settles down to a stationary state. The rate of energy loss in the case of the Earth and the Sun is very low, about enough to run a small electric heater. That big. This means it will take about 1,000 million years for the Earth to run into the Sun. So there's no immediate cause for worry. The change in the orbit of the Earth is too slow to be observed, but the same effect has been observed over the past few years, occurring in the system called PSR 1913 plus 16. Brackets. PSR stands for pulsar, a special type of neutron star that emits regular pulses of radio waves. Closed brackets. This system contains two neutron stars orbiting each other, and the energy they are losing by the emission of the gravitational waves is causing them to spiral in toward each other. Another paragraph. During the gravitational collapse of a star to form a black hole, the movements would be much more rapid, so the rate at which energy is carried away would be much higher. It would therefore not be too long before it settled down to a stationary state. What would this final stage look like? One might suppose that it would depend on all the complex features of a star from which it had formed. Not only its mass and rate of rotation, but also the different densities of various parts of a star, and the complicated movements of the gases within the star. And if black holes were as varied as the objects that collapse to form them, it might be very difficult to make any predictions about black holes in general. We'll be back pretty soon with the next paragraphs of S. Hawkman's book. We're focused on black holes. Over an hour.
Rules. Fights the champion of light. Where hope seems lost, there rides the rebellion. Together they stand ready against the
Hookman.
dark, evil warriors of